Hi everyone, welcome to another Cyber Talk with Nikolai episode. And on today's show we have Carl Madsen. He is Chief Information Security Officer for No Name Security, and I'm your host, Nikolai for APIs. And as you all know, before that we were sharing data ever since computer existed. So we used different technologies to share. We used FTPs and we went to secure FTP. But I think in 2002, when AWS services were getting started, so Jeff Bezos pretty much said, if people not gonna use APIs and what APIs are for, they're gonna be fired. So he explicitly laid out that he doesn't wanna have all these files moving around the company, moving around between their customers, and they usually lead to oversharing and all other problems that are associated with data exchange. So he was pretty explicit that he wanted to establish rules how Amazon functions and make sure those rules are followed. And we'll talk a little bit more about all those rules. And advancing forward 20 years now in 2022, if you look back at previous year and how many things happened, so just alone in previous year we had some notable events, cybersecurity events that were actually had APIs involved, and one of them I think everyone familiar with is when Microsoft Exchange Server exploit happened in March of 2021. During that exploit, actually backend APIs were exploited that led out to essentially taking over certain pieces of Microsoft Exchange Server, and how the functionality was affected, and data was compromised, and email was accessible by threat actors. Then moving forward in April 2021, another incident happened to Experian, and that's what typically called as API leakage. So when Experian introduced API for companies to pull the data, all companies needed basically the data they were looking for. It was credit score and credit history of individuals before the mortgage is issued. What Experian did, they said, okay, if you provide basic information like first name, last name, and then you give address, zip code, and birth date, then you pretty much get back through this API information about what the credit score of the individual is and credit history, how were they paying bills, and so everything was kind of good, but there was issue with API that actually birth date was not validated. So anyone could pretty much put a bunch of zeros in the birth date, and all information was publicly available on anyone. So you can go search through database, pull out the first name, last name, address, and zip code, and then put it into API call, and then you can bring all the data back about credit score for all individuals that you're interested in. So that kind of led to a lot of conversations how to make things secure, and I think basic things that people neglect when they do introduce API is to secure API and also how to control API. So that's kind of like precursor for today's conversations, and I think we're going to have a lot of interesting discussions. So with that said, I'd like to hand it off right now to Carl Madsen, Chief Information Security for No Name. Just introduce himself and maybe give us a little bit an idea what is with No Name Security, why you guys have No Name. So with that said, Carl, it's on to you.
Yeah, absolutely. Thanks, Nikolai. Thanks for the invitation to join. My name is Carl Madsen. I'm the CISO for No Name Security. We're an API security company. And the first question folks usually ask is, how do we get the name No Name? And it was really accidental. It was early when the founders were kind of polling a group of CISOs in this network called CyberStarts for feedback in terms of what was working and not working in API security. They hadn't selected a name yet, and so they put out a survey to this group of CISOs, and using the word No Name as the name of the company. But in the quest for feedback on API security, so many of the CISOs, including myself, part of the feedback that we provided to the founders was that we loved the word No Name, and so the name kind of stuck accidentally as the API security company. So, but as you mentioned, Nikolai, APIs aren't exactly new. 10 years ago, we were using APIs as a utility for a variety of different reasons. And the last few years, both the business cases for API use and the threat landscape have changed. And so I joined the company about 8 months ago, previously having been in financial services. And I think we see, in general, most industries and most large companies and anybody who's creating APIs is sort of in this new world of APIs being a very substantial risk surface. You mentioned a couple of the obvious, the Microsofts of the world. Companies that have sophisticated viewpoints on managing their security and their hygiene have struggled with API security, and so that's the problem that we aim to solve at the center target.
That's great. Thank you for the introduction, Carl. So one thing I would have in mind, and probably the audience would have the same question too, is like why APIs are so important. They were introduced and they were doing certain things, and all of a sudden, like 10 years since Jeff Bezos started, telling their people to do whatever they're supposed to do, now we ended up in a situation that threat actor seems to be paying more attention to APIs, and they're trying to see, so what do we do, and why APIs became so critical.
I think there's two primary like drivers of API use that are very different than they were even just a few years ago. The first is APIs have sort of grew up in IT as a sort of an internal utility that allowed systems to communicate to each other, agnostic to the platforms they're built on. But in the last couple of years, what we definitely see is a exponential growth in the exposure of those API endpoints to public use or to public internet addressability. These used to be internal only IT assets that are now being exposed publicly. And then the second thing is sort of on top of that, the reason they're being exposed publicly is because they're now sort of servicing businesses' primary products and services. So, and a lot of businesses today, an API is a revenue stream. So, like, it is literally the product that the company is selling, or it's the way that the company exposes its services is via an API. And so there's a criticality element of the API, both in terms of business, sort of operational productivity, revenue streams, sensitive data. When all of those APIs were internally to our, in our old school closed network, there was less at stake with minor issues of hygiene and authentication. But when you expose those APIs to the internet, you dramatically raise the stakes in terms of how precise we need to be in allowing those APIs to communicate with sensitive data, to support a critical business process, or to we have companies like cybersecurity companies in general often just they offer their services via API, and so that the API becomes sort of existential to their business succeeding. So I think that the stakes are definitely raised now that the API is that public-facing service revenue stream that it wasn't 5 and 10 years ago.
Got it. So definitely, like, the use of API has grown since then, and I think, Carl, if you don't mind, what have you seen it? What are the common mistakes that typically people do? Because I know API, it's almost like to a lot of people, it's the same thing. It's like, oh, we just share information. It's not really a big deal.
Mhm.
So we put it out there, and then off it goes, and then all of a sudden you see this information on the dark web, and everyone is asking questions like, how did it end up there, and who provided it? So do you have like common things that what is happening, or where people are making mistakes, and if you can kind of give us a little bit color to it and see where it takes?
The way that we generally look at API as an API is an asset, and like every asset, whether it's a host or an endpoint or a laptop, there are like layers of controls. And so the way that we look at APIs is really in like 3 primary layers of control, and then therefore control breakdown. So most of us first think of APIs as a source code, sort of a source code problem to solve, and that is definitely true. That API source code quality and like the design characteristics of the schema are sort of imperative for that API to sort of service its function in a secure way. The next thing beyond source code, though, is probably the most misunderstood, which is the part about configuration in the network. So let's take an API that's been developed according to a secure specification. The developer's done all the right things. But when that API is placed into production, it is subject to variables that the developer may not know about, and the infrastructure and network teams don't necessarily know either. So let's say, for the sake of the example, an API deployed in production that is accidentally addressable both publicly and internally at the same time. That's clearly a kind of like a network misconfiguration problem. The developer didn't have anything to do with that, but that's a type of configuration challenge that we see in production environments. Another example of a production problem would be when an organization uses an API gateway. An API gateway is kind of like the central nervous system of a modern API footprint. And that gateway also has to be configured specifically, for example, to enforce the right authentication policy on every API. And so this area of posture at runtime, this sort of configuration and network policy checks, those are the places that we find organizations are the least equipped to secure their APIs, because we all understand APIs as source code, and source code quality checks and DAST and SaaS scanning and pen testing can be really great. But then in production, that API deployed in production isn't if it's not protected with the network layers of protection or the gateway protections that we expect to see, then it's going to have a problem. And then the third layer, which is another area that I think we generally understand, is like the web application firewall. So your external threat defense, and that can be there's all sorts of threats that a WAF can be very successful at, except for those threats which are specific to the business logic of the API. So volumetric attacks, a WAF is fantastically effective at, or SQL injection. But there are attacks, for example, you mentioned an example where it's simply the user manipulating the API to give it data that's unintentional. That internal business logic attack is very difficult at a network perimeter. So in general, we want to look at API security as it is about source code. It is about the production runtime configuration of the API and where it sits in the network. And then it's also the threat defense of at runtime. Can we see misuse as it's occurring? And so putting those three things together gives a more complete view of API security, and getting to that point with with our customers is what we're aspiring to do, because not every customer is in the same spot. Some customers might have a fantastic source code quality program, and others might have runtime defense excellent. And so we're trying to advise or coach or work with our customers so that all of those control layers are coordinated, they're in sync, and that they're effective.
Things like you mentioned, we need to keep together to make sure that APIs are protected, and it's not just to put web application firewall in front of API and then call it a day and say, yes, now we are secure, but we still have data being leaked out to dark web, or somebody is querying your API without really any restrictions on authentication, and they have access to information that they shouldn't. I think like those are important and critical items that you mentioned. So one thing I would ask is, like, you've been with No Name Security for quite some time right now, like 9 months, as we mentioned, and you guys started something different than any other securities in this company and securing APIs. How would you say what you do differentiates you from others, or maybe even before that? What interesting things are you doing right now with No Name Security that assist with all those aspects of securing API? And because I think by now audience has pretty good understanding what we need to deal with, and not all the layers can be addressed by a single application or a single solution or something like that. But I think from all those perspectives that you put together, if you kind of like peel a little bit one layer and say, here's some pretty cool things we do innovative, and how we try to protect customers or defending organizations against somebody pilfering data through APIs. That would be pretty cool.
Yeah. I think our our difference maker is in the visibility, because the visibility of an organization's entire API ecosystem. That's every protocol, REST and SOAP, gRPC, GraphQL. every environment, whether it's external facing and internal facing. That's sort of like the first distinction, is the ability for the security team to have a vantage point where they can see everything, see the APIs that are going through the development process, see the APIs that are getting staged pre-production, see the ones in production, and what that does is when you can see everything, then you have the chance to diagnose yourself, like where am I? Are there APIs that aren't in the inventory? Are there APIs that have major configuration flaws, and we can kind of tackle the low hanging fruit? So I think that's really our distinguishing characteristic from the start, is just the ability to illuminate the environment, and to some degree everybody has um, every customer has like an error rate, and some customers, that error rate of did the security team know that API was there, or did it not? Is the error rate 1%, or is the error rate 90%? But for our ability to kind of definitively say, here's what the API ecosystem looks like. That 90% of the battle right there, is just to have the security team informed and equipped to then decide what to do to take action. So that visibility comes from having usually several observation points simultaneously. Because especially like you have the great going back to like the basic idea of a WAF, and a WAF can be fantastically effective at protecting APIs, and particular certain threats more than others. But a WAF isn't any good if it's not being used, because if an API is being served and it's not protected by the WAF, first question is does the security team even know that there's 50 APIs enrolled in the WAF for protection, but there's these 15 over here that aren't even enrolled in the WAF. And that isn't to suggest a WAF isn't a useful tool, but if you're not even using it at all, then that's like the first 15 things to address is these APIs over here that are not being protected at all. So that kind of visibility is really, I think, where we first sort of distinguish ourselves at being an additional value, on top of because we already have WAF investments. We've already a lot of bloody money sunk into that, but we can make better use of it by having better visibility.
So I think it's quite important. So how much do you say you can actually see based on your tool or techniques that you use in preventing bad things from happening? So what I'm trying to get at is like when somebody is trying to abuse APIs, and one company built it for one purpose, and since you see some of business logic, how does business logic can be protected from somebody's abusing, just like in case, let's say, of Experian, when they build it and it seems like it should have worked, but then they didn't realize that certain things are publicly available, and then you can easily pretty much put whatever you want and abuse their API and extract information that you're not allowed to have access to.
Well, so one of the challenges historically of defending an API is that an API is custom developed. So in order for let's say to take a legacy approach of detecting misuse, oftentimes would be creating SIM rules and alerts that you'd have to create over time, but they would be specific to that API based on behavioral pattern or volumetric changes, things like that. And so the idea that we can create like customized rules alerts for every API is sort of, it's not practical. So what we employ is we employ like machine learning models for every API. So the way that we break it down, for every API that we see, we develop a machine learning model that basically identifies the pattern of use that represents good behavior, like the user journey through a customer, like a website, for example, so that we can identify those deviations from bad. So, like, give you like just a basic example would be, you go to an e-commerce site and you're shopping for shoes. So you log into the site, you select the shoes that you want to purchase, you add to cart, you check out. And in the checkout process, you have to update the expiration date on your credit card, and you proceed to check out as a sequence of events. That's how the user journey is supposed to occur. But then let's say that the next visitor to the site didn't log in, didn't select a product, just immediately went to providing instructions to change the credit card expiration date. that's not a journey that's intended, like that's not intended human behavior. Is that the first time you visit a site, the first action you're taking is to change the credit card information. So we have this sort of internal business logic flaw, and we can identify those things with machine learning for an API that just helps us understand what was the expected journey and what was the expected behavior of that transaction, and when a deviation occurs. And that's not really a rules based that I can share with another company, or I can subscribe to a feed of external threats. It's really specific to this API and this customer journey, and we can develop that through statistical modeling for an API.
No, that sounds great. And Carl, I think you said something quite important. And a lot of things that when we're trying to deal with cyber incidents, the critical part is to understand the intent. So if we can identify intent, we can essentially prevent incident from happening. So I think you touched upon it. And how does no name do it? So do you guys have, I know we mentioned machine learning, and to what extent actually, and how far do you go? Is it like you're able to identify intent where things about to happen, or you need to have, like you mentioned, all this sort of like not playbook, but customer experience or customer journey, somebody who is accessing API, what they do in normal circumstances before you can build this sort of intent behavior to say, yes, now I understand what is happening, or everything is happening based on machine learning. So you don't really need to build whole lot of hooks, controls, policies are around your product. You can just turn it loose to a certain extent and then let it gather the data. So where would you position this intent identification during this exercise?
On exactly that question is volume, right? So the more an API is used, hundreds and thousands of calls a day, we can develop a very statistically accurate machine learning model for identifying a misuse case. And so, most commonly, when we sort of allow the model to develop, there's really only the only variable that really requires a customer input would be when the customer is actually performing testing. So, for example, if you're doing vulnerability scanning or pen testing, right, that's the kind of thing that you flag as like that's a false positive. And so, other than that, the models themselves, if given a little bit of quantity of API traffic, can be very, very effective, so that there isn't a lot of a lot of need for then fine tuning the rules based on like a more nuanced understanding by the developer. The machine learning models are pretty effective at that. What we really want the security team to be equipped with is options in how to handle and respond to an alert, because there are going to be alerts that are sort of high severity or high criticality that warrant, let's say, a SOC team to probably take an action in the moment, whether that's like an active block or a policy change on a perimeter. A perimeter network device like a WAF or a gateway or something, and then there are alert types where it might be a curious anomaly, but not necessarily one that indicates like a significant data breach. And that's the kind of anomaly that perhaps a developer team needs to investigate further, because it may not indicate a breach, but it may indicate just something is different about the way this API is behaving versus what it's been historically. And that may be something, for example, where it's just simply a change in the API schema has resulted in an unintended consequence. And so every organization goes through a little bit of a learning curve when they're sort of receiving the machine learning alerts to say, like, yes, these are things that indicate a misuse is in progress, and then other things that might indicate there's a change in the environment, or perhaps even like a system failure where we're detecting an anomaly, but the anomaly is really because there's a system involved in this sequence that's just not responding, and that's the anomaly that we might see.
Got it, got it. So let's say if a typical organization tries to deploy your solution, so where do you think this learning curve takes them? Is it like 2 weeks, 3 months, 6 months, or because some solutions out there when they talk about machine learning, and I think they help people to develop misconception when they say, well, it's machine learning AI, you just turn it loose and everything just magically happens on the back end. So we all know kind of like there's different machine learning, and some will do better job, some will do worse job. But in your case, it's like how long somebody would need to have your solution employed before they see the results. coming on the other end to say, yes, it looks pretty cool, and I think data has been gathered. And you already mentioned, like, the more you use APIs, the more data it collects, the
Yep.
better model response. But what have you seen out there, and how soon organizations realize the benefit of having it?
Well, usually what we're doing, let's take, I guess, an average organization. What we do is we integrate typically at a public cloud layer, like an AWS account or an Azure account or a GCP account. And let's just say, for the sake of discussion, let's say the company has 10 AWS accounts. What we always try to do is start with an account that maybe that has live production traffic, and start there. Usually, in a case of like an AWS account, we're probably going to have a pretty good baseline of the. We'll have the inventory, we'll have the configuration checks, and we'll have the behavioral machine learning models, probably in about 2 to 3 days. But that doesn't mean that the organization is yet sort of ready to consume that. So rather than roll it out exactly all over 10 AWS accounts instantly, it is important for an organization to pause after that first data set and say, where are our problems? What are the processes and procedures that we need to put in place? Like a perfect example would be, when we turn on an AWS account and we can see the APIs and we see the traffic for the first time. It's unusual that the organization has yet thought through: am I going to take my misconfigurations, and which team are they going to go to? Am I going to open up a Slack channel? Am I going to fire up PagerDuty alerts? Am I going to open up Jira tickets? Do I send this stuff to my Splunk or my Sumo or my Devo SIM instance? And so what we do suggest is that after you do that first account run, is the organization ought to pause, decide how it's going to handle and dispose of misconfigurations and anomalies before you keep going, because the last thing you want is to have 5 alerts turn into 500 that you can't respond to because you haven't decided yet procedurally how to handle it. It doesn't help anybody just to have a longer to-do list if we haven't sort of decided how to operationalize that. So, but on an AWS or an Azure account, it's probably 2 to 3 days on average. We're pretty much done at that point. And might be some fine tuning to get right. Things like organizations may have internal naming conventions, or like application or department product names that they like to use, and so we might change some of the naming and the tagging logic to get it so it reflects the organization's internal logic.
Kind of like cybersecurity controls each organization deploys. So there is a concept of, some people call it defense in depth, the other call it expense in depth. There's also defense in breadth. So because we're not really trying to kill anyone before they get to the crown jewels, but we're just trying to put more controls in place so we can detect events before they happen. So if you look at the set of controls people have, and right now we discussed some of them, like web application firewalls and having product like yours, would you suggest that some of the things that your application does would eliminate the need for, let's say, web application firewall, or organization would still need to deploy to protect their APIs, WAFs, and then add additional products?
Think it would be pretty unusual that an organization is not better served by having a WAF than having not having one. So, and the same goes with an API gateway. An API gateway is the nervous system of the API footprint. And so, what we want to do is we want to make the use of that gateway better. If it's got configuration problems or inventory problems, we want the API gateway to be better and healthier than where it started from. And the same goes with application firewall, because we sort of take as an article of faith that most companies will have something also in addition to APIs, for which having a web application firewall is still going to be a great idea. There still are threat types that a web application firewall is very effective at defending against for APIs. Like a denial of service attack is a perfect example. Like if a company has a WAF, absolutely, that's the right place to do it. So whether it's the WAF or the gateway, we think that we can help the organization make better use out of the investment it's making in those layers by adding the missing pieces to the recipe of API security, without suggesting that those other elements go away. I don't know that anybody could project 10 years from now exactly what the application landscape will look like, but I don't see it foreseeable and advisable that anybody should be considering getting rid of a WAF. Let's just make better use out of it.
Right. It sounds like it's more complementary product to all those existing controls in place, and eliminates sort of highlights the issue that API still can be abused if you have application firewall or APIs gateways you don't really control, or they don't see what is going on. They just provide protection against them like brute force and so on. But if somebody is trying to abuse your APIs, they can still bypass those controls easily and do what they need to do. All right, that sounds good. So, Carl, one question I had, it's from your experience, do you have some cool anecdotal cases to share with us that you participated while at No Name Security involved APIs?
Yeah, there's one kind of interesting case. One thing to remember about APIs is most of us as like a consumer, we all got smartphones and iPhones that are API based applications. But there's a lot of things in the world that are started and stopped via an API call. And so one of those things is television. And so we did have a customer that was a large entertainment organization, and this particular organization broadcasts its signal, and then it gets picked up by other companies, television providers and the Netflixes and HBOs of the world, et cetera. But the company that actually produces that content, what we discovered in in an early evaluation, was that they were broadcasting a sort of a live feed from an API that was very, very easily compromised. So there was like this is an entertainment organization that could have had its entire global footprint just erased instantly, had this particular API been discovered to be very unauthenticated and vulnerable, which it was. And so this was a case where even in the process of flipping on No Name, we didn't even get to the point of even reading out the results. The security team basically declared like incident response, kind of critical response. And I wish I could share the name of the organization because you'd all know which television programs I'm talking about. But an API abuse could literally stop the broadcast of a major network. And that type of thing is interesting because when the security team sees these things for the first time, they're I think what we find a lot of security teams, they learn something about their organization that they didn't know that's how it worked. Like they didn't know that streaming service was actually initiated by an API call. And so that was one of a couple that we've seen that is kind of high profile, like really, really high impact. This particular company, its entire revenue stream would have just been shut down had this exposure been exploited.
No, and sometimes what you mention is like seeing is believing. So cybersecurity sees a lot of different things throughout the years and through experiences, but when you don't experience anything and then you kind of think one way how it's gonna manifest itself, what is gonna happen, and you expect certain things, but seeing in real life events unfold, and it certainly brings a lot of experience and learning to cybersecurity team.
And the other thing, Nikolai, I mentioned this anecdotally, but we see this almost every organization, is the circumstance where an API is publicly addressable and internally addressable at the same time. And most of the time, our customers, they don't believe it. Like, no, that's an internal API. Like, well,
Mhm.
let's show you. We can show you it's actually accessible from the wild. And that's not a point of finger. Like everybody has that at least somewhere in their environment. And so that's like it's also the easiest thing to fix too. So
Yep, seeing is believing. All right, seems like we're coming up at the top of our hour for today's cyber talk with Nikolai. So, Carl, do you have any parting thoughts that you would like to leave audience with before I wrap it up?
yeah, I think I talked a little bit about source code. There's the posture management and runtime defenses. All of those things, like that's what we obsess over. All of those things all day long. So you have somebody in No Name, we can talk about source code security and what we do there. We can talk about best practices and operationalization. Just would love to have the dialogue, and that's what we're here for.
Sounds good. Thank you, Carl. Certainly appreciate you, and thanks the audience for attending once again another episode with Cyber Talk with Nikolai. So the objective is to learn, to educate, and to understand better what we have to deal with on day-to-day basis and how to make your organization secure. So stay tuned, and we're stronger together. Thank you.